Hello and welcome to today's webinar, Simulation within Inventor Professional. This webinar is brought to you by Live Lab Learning, which is a subsidiary of Academic Corporation, a wholly owned applied software company created to provide world-class training. This is Marcia Tucker and I'm delighted to be your moderator today. Throughout our presentation, we encourage you to interact with us by typing in questions and comments using the questions pane. We'll be answering all the questions at the end of the presentation. This webinar will be recorded and will be available to you online on our YouTube channel. Please take note of our upcoming events, and we have a livelablearning.com website which lists all of our classes that are upcoming. In addition to, we will be in Orlando at the Motor and Drive Show, which is this week. Then we have a subscription webinar January 22nd, and then we have on February the 5th Optimized Factory Layout in 2D. So please feel free to register for any of those, or you can contact me with any other additional questions, which my contact information is at the bottom of the page. So we are pleased to have Jason Miles, our Senior Applications Manager, with us today for the presentation. And due to his in-depth knowledge of this class and how he teaches it, originally we thought we could cover this in one seminar. Due to the number of people that enrolled, we've decided to do a more in-depth presentation, so we're going to have this in a three-part series. As you can see, the next series is February the 26th. And then the last series will be March the 12th. So please feel free to log that on your calendar ahead of time. You will be receiving an invitation to register for those webinars just like you did this one. But it has been expanded to be more in-depth so that you can maximize the usage of your software. So prior to joining Applied Software, Jason served as a product engineer at Thomasville Furniture. He later worked at their corporate office, which is Furniture Brands International, as a digital design specialist. He holds a bachelor's degree in industrial drafting and design from Appalachian State University with a minor in computer information systems. Due to his wealth of design experience and understanding firsthand the challenges and opportunities of utilizing Autodesk software, we find him a real value in the manufacturing industry. And Jason, I will turn it over to you.
All right. Thank you, Marcia. So once again, I'd like to thank everyone for joining us today. Today, we're going to focus on the stress analysis side of the Autodesk Inventor. And with that, I want to explain that the stress analysis in Inventor is an add-on that can be utilized in the assembly environment, the part environment, and also the sheet metal environment. Now, within the stress analysis, we actually have the capability of performing two types of analysis. The first one being the static analysis, and which that means that we're able to simulate stress, strain, and deformation. The second one is known as modal analysis, and this provides us the means to find natural frequencies of vibration and mode shapes of mechanical designs. Now, the key thing that once we run these simulations is we need to be able to validate. So what we have the capability of obtaining from these simulations are 3D volume plots. More or less, that means the nice visualization of our model as it's deforming. Also, we can create reports for any type of results. And also, what I really like, and we'll see this later on, is the ability to perform parametric studies to refine your design. Now, today, during the demonstration, we're going to end up running two simulations. The first one is going to be the modal analysis, and with that we are going to create a simulation from this model that you see to the right. This is going to be known as the pivot bracket. We're going to override the model material with a different material within the analysis environment. We're going to specify some constraints. We're going to run the simulation, and then we're going to view and interpret the results. Now, once we run this analysis, we're going to take it a step further, and we are going to run a parametric static analysis. This is going to give us the ability to where we're going to actually not waste the information that we input on the modal analysis. So we're going to copy that simulation, and we're going to utilize the analysis parameters to evaluate how to refine the weight of the model, because that is the key thing that I'm looking at today for running this simulation, is how much material can we save and our parts still be structurally sound. Then we're going to generate configurations of the dimensions, and then we'll modify any design constraints and view the results based on those changes. So what I'm going to do now is we're going to jump right into Inventor, and you'll notice this is our part, the pivot bracket. And the first thing that we're going to do is I'm going to jump into the stress analysis environment. And you'll notice that we have all these nice tools up in our ribbon. So let's create a simulation. So it is going to be a modal analysis, and I'm just going to go ahead and give this a name. Okay, and I want to make sure here I do want to have 8 modes. So we'll go ahead and say OK. Now I want you to notice over here to the left, just like if we were modeling in a part environment, you'll notice that over here in my browser that I have information. And once I assign, let's say, materials or constraints or loads, it's going to start to populate. So that way I'll start having a history. So the first thing that I want to do is the way that the simulation ribbon is set up, it's really a left to right workflow. So you'll notice here I'm going to go ahead and assign a material, and what it's showing right now is generic. So we're going to, let's add a material as aluminum 6061. And if I move to the right on the constraints, I'm going to add a fixed constraint to this particular part. That way it's going to lock it down. I want to use that inside face. Now the next thing that I want to do is, if you've ever heard of meshing in any kind of simulation software, Inventor works exactly the same way. So if I look at our mesh view, you'll notice that Inventor creates all these little triangles on our part. This is the way that Inventor does all of its mathematical calculations to give us the needed information for this simulation. Okay, once I have that, we're pretty much good to go just to get this modal analysis. So I'm going to go ahead and turn this mesh view off, and let's go ahead and let's run the simulation. Now you're going to notice that once it has ran, that our results has populated. Okay, we'll notice that we have the first mode, we got a F1, okay, and it has a check by it. So that means that that is what we're actually seeing over here in our graphics window. Okay, and there are nodes for the mod shapes corresponding to each natural frequency going down. Okay. Now what I can do if I want to see any of these other modal frequencies, the only thing that I need to do is double click one of these and you'll notice how it changed. Okay, so I'll go back to number 1 at that 1215.99 hertz of that natural frequency, and we can see here I can actually animate it. Okay, and we can see the changes there. Now I'm going to go back to number 3. And let's see what we have here during that animation. It's a little bit more drastic. Okay. Now, if you know anything about modal frequency, I'll give you an example of why we might use modal frequency. So for instance, let's say that you were trying to simulate maybe a muffler. You know how we can have vibrations and things like that, and all of that stuff can affect some of the integrity of our part. So that might be a good example of why you would want to perform a modal frequency. Now with that, I want to move on, and we want to look at what it would look like if we were going to perform a static analysis. Okay. So what I can do is we've already put in a little bit of work, as in adding our material, adding our constraints. So I can actually copy this simulation Okay, let me close out this one dialog box here. There we go. Now, you'll notice here that it's copied all of the properties that we've set up in the initial one. So I'm going to go ahead and I'm going to edit this modal simulation, and what we're going to do is I'm going to go ahead and call this parametric. This is going to be a parametric dimension design objective. Okay, and once I have that, I can go ahead and say OK. Now, I'm a big fan of performing these parametric design studies. The reason being is I can utilize some of the parameters to make different configurations of this part without having to run multiple separate simulations. So for instance, we'll go ahead and click on parametric table. We'll notice down here that it's broken up into design constraints and parameters. So I want to see the parameters that are being utilized for this part. What I'm going to be checking is the thickness of my part, which is the parameter D2. So that's the one I'm going to utilize. And then there's a couple things that I want to look at. So let's say that I want to have 3 different thicknesses. So down here at the bottom, you'll notice that I have this slide bar but I only have one value, which is the 12 millimeters. So we can actually set up a range. So let's say, for instance, I want it to be 6 through 12. And for that, I want to have 3 different configurations. So the way that I can do that is I can have a colon and put in 3. So now I'm going to have a configuration of 6, 9, and 12 once I enter that. Now the slide bar here, it is active, but first I have to generate those new configurations. So for instance, if you ever run into it to where if you slide this and you get not available, it's because those have not been configured yet, the 6 or the 9. So what I can do is anywhere down here on this row, I can right click and I can choose generate all configurations. Now whenever I slide this bar down at the bottom, notice the thickness here. So instead of having 3 separate models to perform this simulation, I'm using the same model. I'm just taking advantage of that parameter. Now the next thing that I want to do is we need to include some design constraints. So down here I'm going to add a design constraint, and you'll notice with this dialog box, the main thing that I mentioned earlier is we want to really pay attention to the mass of our part, but we also want to make sure that it falls into a specific safety factor. So I'm going to go ahead and we're going to add mass, and I'm going to do the same thing again. I'm going to grab safety factor, and I want to make sure that all geometry is selected. Okay. Now, when we have that, there's a couple things that I want to add. For instance, in the mass, well, actually, let's change this here for a second. Let's take that. Let's look at actually the von Mises stress. Okay. So for the von Mises stress, I want the maximum limit to be, let's say 20, but I want it to be the upper limit. So we're going to set that to 20, and then also I want to keep this at 1.5 for the safety factor. Now once we have that, one thing that I need to have on this, since this is a static simulation, is I need to have some kind of load on my part. So we're going to add a force to this face, and I'm going to set this up as, let's say, 200 newtons. Okay. Now, what we want to do here is we're going to modify some convergence settings. So whenever it's running the iterations or running the solve, the convergent is when everything starts to level out and it's starting to get a consistent results. So that's when everything is converging. So with Inventor, it actually performs an automatic HP refinement for parts. So in this case, we want to add an additional H refinement iteration. And what H refinement does, it increases the number of mesh elements in areas where the results need improvements. So maybe it might need a little bit more, maybe in this area here, and maybe on the back side of that edge. Okay. The P refinement increases the polynomial degree of the selected elements in the high stress areas to improve the accuracy of the results. So we want to be as accurate as possible, so the great thing is Inventor does that stuff for us. So I'm going to go ahead and refine my maximum number of H refinements, and I'm going to just set that to 1. Okay, so far we've set up our parametric table. We've utilizing the material from the previous modal analysis. We've got our constraints, so we have a fixed position, and then we've also added a force to our pivot bracket at this location. So now we're ready to go ahead and simulate it. Okay, so you'll notice in our results all the different areas that we can look at. Well, like I said, we're really wanting to look at the von Mises stress and then also how the weight is affected. Okay, now down at the bottom you'll notice that in our von Mises stress, and this is why I said that I'm a big fan of a parametric table, is you'll notice at the current value of the 12 millimeter thick, we got a green circle here with our von Mises stress, letting us know that this configuration follows within the limits that we have set. So this one here, you'll notice that it is okay, and it meets all the criteria. The next thing that I can do is here for the mass, since we're wanting to really pay attention to the weight to see if we can possibly save some cost, is I can change this to minimize, and you'll notice that it has changed the thickness of our part, which the current value here is 9 millimeters, and notice that we have a check on our mass, and then also with the criteria set up for the von Mises stress, it is satisfied there as well. Now, that was the minimum value that would fall underneath those categories. So if I would actually take this slider and drop it down to the 6 millimeter thickness, notice what happened. It is now out of the range that we had set for the von Mises. All right, so let's go ahead and I'm going to set it back to 9. And let's see what it looks like when we go in here and animate it. Okay, it looks pretty good. And here, you know, we get a little bit the stress up here at the top. Now, another thing that we can do is if I stop this, sometimes you're going to have models that they're going to have very little deformation. So right now in my display, we're looking at actual. Like I said, it's very minute. You can actually go in here and adjust this and just make it a little bit more drastic. So let's just say if I adjusted this by 1, Still the same results, it's just giving you a more drastic visual. Okay, so those can come in handy. Another thing that we have, and I can't pull over this little animation window, but you do have the capability of recording this. So if you need to record this and save it as a type of media file to send to someone, you could do that. Or maybe possibly add a video to maybe a PowerPoint for a presentation. Also, we have certain things that we can do. So I can look at where is that maximum value. Okay, and that'll give me a little, what is known as a probe label, if you need to show that. And then you also have the minimum value. That we can show. And also, if you're just wanting to go around in here and maybe probe on certain locations, we can do that as well. Okay, if you wanted to get, just for your own curiosity, after the simulation is ran, you want to go through and maybe probe a couple locations. So we can do that. Also, another great thing that I like is being able to generate reports. So for instance, I want to maybe look at an XY plot for my part. And what this is going to show in this graph is the results of the component over the range of a parameter. So you'll notice we have our von Mises stress over here. And then these down here are the different values that I had listed for the different configurations or the thicknesses. So you'll notice here at 6, we're at 25.557. At 9, we're at 10.534. And then also down at 12, 6.642. So there's just a nice visual of the or a graph that we can see for that extrusion 1 versus the criteria we set for the von Mises. Another great thing, if you have to have any kind of documentation that you need to actually put in a report to hand off to a client or someone internally, we can actually go in and make a little bit more in-depth report. Okay, I'm going to call this, we'll leave that as stress analysis report. The properties here, you can either, like it's saying here, all properties with values, or you can make a custom and you can go through and choose which ones you want to include. So I'm going to leave this as the default. Now in the Simulations tab, I'm wanting to, let's only see or create a report for the parametric study. So I'm going to leave this unselected for the modal. And I'm going to come down and expand some of these. And I'm going to choose which items I want to include. All right, so material and loads, that's fine. Constraints, that's fine. Now here, I'm only wanting to see the von Mises stress, so I can uncheck some of these other results. or we can put in the safety factor here. That's fine. And I'll leave in the reaction force. And I'm going to do the same thing on the other two configurations. And the next thing that we have is we can choose what kind of format we need. You'll see we got web page multiple files, web page single file, and then you can either do a rich text format. I'm going to leave it as web page multiple files. I'm going to say OK there. It's going through and creating it. And what we end up with is this document here. And on the first page of that report, you can actually go ahead and make this customized. So maybe you want to put your company's logo here, so you're able to do that. But I want you to look down at all the information that we have. It tells you the part, when it was created, who ran the simulation. It even breaks it down to all these properties that I left selected, like who actually created this part, anything else that had a value in it. We got the physical, and then also all of our parametric settings. Okay, here's our override material. And then we notice that it starts breaking it down to the force that we added, the face that was selected, the constraint, that fixed constraint that I added to the inside face. And then we start getting our results. So for that current value, you'll see all the information that it gives us. Okay, so the safety factor there was 10.76. And you'll notice that it goes down to the von Mises. So this is a great report. Like I said, you could give to a client or maybe your engineering manager, so he can look over and see everything that was set up on the simulation to make sure, you know, that the certain design criteria or requirements are met. So it's a nice little tool. Now, let me move this back over. Now with that being said, I hope that you can see how the ease of use for just setting up a stress analysis can be. You can see that the pros of using a parametric table. It can cut out of having to possibly have 3 different models to run 3 truly separate simulations. So this way it saves time. Running these simulations not only can save, you know, cost in regards to you know, nowadays, you know, you're still going to probably want to do some kind of mock-up or sample of your product. But the great thing about the simulation is it can cut down on the number of mock-ups or that you need to produce. Because by running these simulations, it can point you in the right direction in your design process. Now, with that being said, I'd like to go ahead and turn this back over to Marcia. And
Thank you, Jason. That was excellent. So we do have a question, and please feel free to be typing them in the pardon me, in the window pane to the right. But we are and have recorded this webinar, and we will be including the link in a confirmation email that we will send out by midday tomorrow, I think would be a satisfactory timeline for the marketing department. And I don't see any other questions at this time, Jason. So if you haven't already, please visit our Live Lab Learning on the Facebook and like our page so that you can receive the latest information and special offers. When you visit our website, livelablearning.com, as you can see noted at the bottom of this slide here, there's a complete schedule of our upcoming training and future informational webinars, in addition to tidbits along with software updates. Thanks for joining us today. We hope you found this webinar informative and helpful to your business. We look forward to seeing you on our next Part 2 series of this webinar on February the 26th. Part 3 will be March the 12th. And thank you very much.